Let's go over some practice queries using functions. Now remember, a function is kind of a pre-made, pre-coded bit of code that we don't have to really worry about. Someone has already created it and named it, given it a name. What we do is we'll give our data as input so that that function can do something, process it, do something with it, format it, whatever that might be, without us having to really worry about it. We just have to know the name of it and give it the input. Then we can get the output that we desire. So we have to choose the right function for what output we need, and we have to know what input to give it. That input is called parameters. So let's practice with those and we can see how those work. I'm going to be using the bike database, so I'm going to run that and make sure my bike is my current database. And let's just take a look at everything that's in the store table. Now we have 3 stores, their name, phone number, email, street, city, state, and zip, and they each have the primary key 1, 2, 3. Now let's start off with the concat function. So in this instance we want the output of that function to show up as a column in our result set table. So I'm going to just put it inside the select statement for this one. And what the concat function does is it takes all the parameters and just puts them together. It stands for concatenation, which is just putting them together. So if I wanted to make perhaps maybe a sentence, well, let's just start with 2 columns for now. So we're going to type in 2 column names and email. So those are our 2 parameters. We have parens that always follow a function name. The function name is concat. The parens always follow a function name. Sometimes the parens hold parameters. So this is the input that's going into our function, the store name and the email. We know that the concat function is pre-made code that someone put together, but what it's going to do is it's going to take these 2 inputs, the 2 parameters that were separated by a comma, and it's going to put them together. So if we run, oh, I've got to put what table that those columns are from, or I won't know. And if I run this now, you'll see it threw together, and it was very literally together, the bike name and the email with absolutely no space in between. Just shoved them together. Okay, so if you did want to, of course, add a space with the concat, you can have a number of different parameters. You could put empty quotes with a space in between, and that would give you a little bit of a space between those 2. You could even throw in other strings that you choose, the with a space after it, and I have to put commas in between all of these. The store name, and then we could put something like email is, and you could even add a period at the end, whatever you wanted to do, and it will make some output that looks like that. Notice it's got kind of a crazy heading name now because it's just going to use the whole entire function and all the parameters as the heading name, everything that's there. And so we could, it would be a good place for a alias, stores, emails, or something like that. Oh, and this, notice how it thinks I've ended the alias right here because I had a possessive quote in there. So we do have to either, use a backslash to ignore that out, put it right before the one that you want to kind of ignore, or I could have used double quotes on the outside and single quotes on the inside, and that would have worked as well. But yeah, so remember, this is a very literal system. It's going to take exactly what you do. It doesn't understand that you wanted that as apostrophe, so you have to be very careful. Okay, then you would get a much nicer meaning heading there. Okay, so that was the concat function. If we were to add something like the store's name, or the email is, or maybe we want to put the store number is, and we put store ID, which is not the email anymore for our alias, but if we were to run that, it now becomes, the output of this function now becomes a string. Even though store ID was an integer to begin with, it's going to be concatenated in with all the rest of the strings, and it's going to become a part of that string. So not only does it put different things together, it will change the data types sometimes. So when you send parameters in as a certain data type for some functions, it may output as a different data type. So keep that in mind as you're running some of these functions. All right, let's try the left function. And what the left function is going to do is it's going to return a number of characters from the left of a string. So we had all those bike product names. So all the names of the bikes, those big long names. So if we say, let's just look at those product names really fast just so we can see what they look like from the product table. And they were these long names with the years at the end, the name of the brand at the beginning. So if we wanted to just grab a certain number of characters from the left of that string, we can say, okay, I want to get the left side of the string product name, and I want to return 15 characters. And you could run that, and you will see you get 15 characters back. Even that space in between the two words is counted as one of those characters. Apostrophes, special symbols, anything that's taking up a spot would count. So it's going to get 15 from the left. Now you're wondering, well, why would you do that? If you had column names that you knew the exact numbers between words, that would work, but you sometimes will use functions inside of other functions. So this function may become a parameter for a different function, so they're kind of nested inside of each other. So this may be one that you might use with another function as well. All right, so there's also a similar one that is right, and it will go to the right or the end of the string and return 15 characters counting backwards through the string. So it goes to the end, counts 15 places, the spaces, the dashes, the apostrophe, everything all counts in those 15. And it will return that. Now that wasn't, I mean, some of these functions I'll run today are not very logical. Like, why would you do that? I don't see the purpose of that. But again, you may use this with a different function, or you may have columns that are more uniform in length that this might work with. Today our purpose is just to understand what the function is doing, even if it may not be very logical for us. Okay, there's also one called trim, ltrim and rtrim. So sometimes data goes into the database with spaces before and after whatever they entered. And in order to use it then as output for your program or wherever the output's going, you want to make sure all those leading and trailing spaces, beginning and ending spaces, are eliminated. So we're going to try one called trim. And since we don't really have spaces in any of the bike databases, I'm going to go ahead and just type in my own little string here, and I'm going to purposely put 2 spaces, and I'm going to say, just give it a string, put a couple more spaces, and that's going to be my string. And I've got 2 leading spaces, 2 trailing spaces here on this one, and I don't have to put a table name here because it's not really coming from any table, it's just a string. If I run this, it will take off both the 2 spaces at the beginning and the 2 spaces at the end. It's kind of hard to see that. You can kind of see at the beginning there's no spaces, but that is what it's doing. If I said, okay, I just want to trim off the right or trailing spaces, you'll see you can kind of see those 2 spaces, but the end one would be trimmed off. And then ltrim just takes it away from the leading or beginning of the string. Okay, so it's kind of hard to see those. So let's combine this with another function. And let's just look at this new function first before we combine them. If I say length here, I get a length of everything that's in the string. Again, if it was a column name, it would give me the length of all that was in there. So it's counting the 2 spaces here, and then the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. spaces onto those two, which gives us a length of 14 characters in there. Now if I go in and I say, okay, now I'm going to use this with the trim function nested inside of the length function, and notice I've got to have a set of parens for each function, which gives me a double set here, one for length and one for trim, and I run this, it will give me a length of 10 because it trimmed off the 2 at the beginning and the 2 at the end. Now the length, once the inside nested one would run first, trimming up that string, then it would count the length of what was left over after it was trimmed and give me 10. So do you see how you can nest functions inside of other functions and have them work for you? Okay, and then again, if we do ltrim, we can see it brings back the 2. It'll still count the 2 on the right because we only trimmed on the left, and if we do rtrim, it gives us the same because now it's counting the 2 on the left because we trimmed off the ones on the right. All right, so there was trim, ltrim, rtrim, and length. Okay, there's another one, another set that kind of go together, and that's the lower and the upper. So this time let's use a column name. If we look at all of those store names that we had before, whoops, from the store table, we see that it's got like initial caps. The first of each word is initial or is capital, and the rest are underscore or lowercase. So if we use the function upper, put in the input of the store name as the parameter, it will make every single character in that whole string an uppercase character. So again, data may have gone into the database in lowercase. Maybe you had a 2-digit state in the, it was reduced down to varchar2 or char2 to keep it those 2 characters, but you didn't specify you had to have an uppercase. So at this point, when you want it to come out of the database, maybe you want to make sure they're all very similar and all of them are capitals, so you might run something like this as you bring that out of the database. Lower is the other one that's similar, but it will bring everything into lowercase. Even those initial caps are now lowercase. So upper and lower will format your string to be either uppercase or lowercase. All right, let's do a little more complicated one, but it's really cool. So this one is called locate, and I'm going to put a comment here just so we can kind of see the parameters that are going in here. These are just little placeholders for me to remember what goes into locate and what the parameters are doing. So the parameters here are something you'd have to memorize or look up. You're going to want to find something locate something inside of a string and know where that piece that you're locating started. So find is the first parameter. What do you want to find? And then where are you searching for this thing you're looking for? And at what position do you want to start looking for that? And this one I'm going to put square brackets. You don't need to do square brackets in the actual function, but I'm going to put square brackets just because this one's optional. You don't have to have this third parameter, but you would need to have these first 2 parameters for sure. Okay, so that's what we're looking at with the locate function. We're finding where a certain part starts, where a certain character starts in another larger set of data. All right, so if we say something like select the product name, and we'll go ahead and just put that for now from the product table, we have that big long name of the bike, right? So if we wanted to go ahead and use the locate function, we can actually do that now it doesn't have to be in the select statement. You could do something like where locate the string girl. So some of those product names had the word girl in there because they were girls' bikes, and it actually said it in their name. And where do we want to search for that word girl? We want to search for it in the product name. And we could even put, we want to start at the first character, or we could leave that off and we get the same thing because it would by default start at the beginning. Okay, so if we run this, what's going to happen is we're going to get some products returned here. So it's going to show the whole product name, but the where is filtering it down to when this condition is true, meaning we got a number back from here. So let's put that same function inside of our select so we can see what that output looks like. Okay, because you're going to see whatever's in the select is what you're going to see in the result set. Okay, so what it's saying is we are seeing the word girl at character number 9 for this first one. If I count over 9 characters, 1, 2, 3, 4, 5, 6, 7, 8's the space, 9 is where G in girl starts. That is where it started to see that substring that I put in here, right? So it says, okay, within the product name, we found the girl is starting at character 9. Okay, so that is what's happening here. So we're getting a positive number as a result back from this condition. You could also, if it makes more sense to you, say something like, as long as it found something and it was greater than 0, right? It's not, they didn't find anything, then show that one. If I take the where off completely, it's going to show everything of where it found 0 at. Oh, I need to take it all off, not just. And some of them did not have the word girl in them at all. So it returns a 0. And we scroll down, and there's where it found that 9. And so that one did find something. So the where was filtering out all those zeros, basically. So this locate returns, and I'm going to put it up here, returns an integer of where it's located in the number of characters in your data. All right. Let's go ahead and do another one that's kind of fun, and that one's called substring. And I'm going to type in the parameters, just little placeholders here, just so we know what's going on. So here again, this is the string that we're searching in. And where do we want to start our search at within that string? And then what length of characters are we going to return from that start point on? Okay, so this one's going to return an actual string to us. So we're getting a piece of a string from another string, and exactly how much we get from that determines where we start and how many characters we're returning from that. Okay, so we're going to go ahead and look at that product name again. So we're pretty familiar with it at this point. And we're going to type in the name of the function. And we're going to put as the first parameter, what string are we looking at? The product name, that whole big string of the whole entire name of the bike. Where do we want to start at? Let's start at character number 9 and return the next 6 characters after that position. And this is the product table. I highlighted red there, but okay. So then it's going to go in and it's going to count 9 spaces. Remember, some of these had the word Electra or truck or something in front of them, so some of them had gone over 9 spaces. In fact, let's put the product name in here so we can kind of see the original. So we're adding a new column just so it took out the 9 before, got to the 9th space, so 1, 2, 3, 4, 5, 6, 7, 8, and 9, which is A, and then returned 6 more spaces after it. Okay, so that's what we're getting from the substring. Again, you're like, oh, what use is that? Again, you would probably use this with another function. Maybe you'll use the left or the locate or something as a function inside of another function. In fact, let's try that. So this time we're going to kind of combine these two things, and we're not only going to locate the integer where girl starts, but we're going to try to return just the word, the 6 characters where the G in girl starts. So we can go ahead and use this position, which told us where that locate, where girl started, I'm going to copy that, and I'm going to replace the second parameter with that entire function. Now remember, this returns an integer. So it's going to return 0 if it doesn't have girl in the name. It's going to return 9 for some of those that found girl at the 9th space, or 33 if it's found it at the 33rd space. And then it's going to just return 6 characters after it starts finding that. So now if I run this, you'll see that for a lot of them it doesn't return anything because I don't have a where in there. But for the ones that do have a substring in it, it returns the 6 characters. GIRL''S, 1, 2, 3, 4, 5, 6. So now we're getting the exact girl word out of there. And you can see that now you can start thinking of more logical ways that you might want to grab things out of other strings or use it in a where clause so that you can just get those, that because you don't know where it is in the string, so you kind of have to search for it. You locate it, use that as a parameter of another function as the start position. Anyway, so you can see how putting these together, using functions inside of other functions, can start to get you very specific results back from your database, which is super cool. Okay, so we've looked at a lot of the string functions, which have to do with strings. Now let's look at some other types of functions. But before we get into those, I would now practice with yourself and just see if you can do some of these things on your own. For example, you could take the art database, the VArt database, and look for the word woman inside of all the artwork titles and see if you can actually return that word woman, and just kind of practice with this and see if you can figure some of these things out on your own and just kind of play with them. That's how you're going to learn. But let's go ahead and go on now and look at some of the more numeric functions. So now we're looking at different functions that work with numbers. And I'm going to go back, make sure you're using the bike database, which I think I'm already on. And we're going to go ahead and let me get some spaces here so I'll higher. All right. We're going to take a look at those prices again. So now we can do some math on some numbers. And we have a list price from that product table that we can play around with. So we have all these prices of all the bikes, and you'll see that most of them end in 99 or 00. And we can now look at some of the different numeric functions. One of the numeric functions is the round function. If we round these, you'll notice that let's look at the first bike. The first bike is $379.99. Now if we round every single price, that's going to round up to the next or round up or down depending on what the decimal place is. But since it was 0.99, it rounded up to 380. So there is this function. You could also place right now the default is 0 decimal places, but you could say I want 1 decimal place. We could run that and it would give you 1 decimal place. And you could also give it 2, which is actually going to put it back down where it was because that's as high, if you round it by 2 decimal places, that's where it already was. And then from 3 on up, it would just be giving you zeros because we don't really have any more decimal places after that. But you can use a second parameter here that would give you number of decimal places to round to. Okay, so that's how the round function works. There's some that seem similar, but they're a little bit different. We have one that's called ceiling and another that's called floor. Now, since these were all 0.999, it doesn't work really well, so I'm just going to throw my own number in here. So if I say 12.2, and I don't really need a from because it's not really a table what we're looking at, it's going to make that go to the next highest whole number. So that's what ceiling is going to do, even though round would have made it 12 because it would have said, oh, it's only 0.2, it's 0.5 and below, so I would have rounded that down to 12. But ceiling, no matter what the decimal place, even if it was 12.1, is always going to go to the next highest round number. And obviously 0.9 would still go to the next highest round number. But floor does the opposite. If it was 12.9 and I said floor, it's always going to go down to the next whole number. No matter how high this decimal place is, it's going to go down to the next lower number. Okay, so that's how floor and ceiling will work. Just in case you don't want to round it, you want to go up or down, then you use floor or ceiling. All right, you can also format numbers. So what if we wanted these prices of the bikes to have a comma in them, maybe a dollar sign or something like that? How can we make it look a little different? Okay, you can use the format function, and list price would be the first parameter. What do you want to format? List price. You can also put the number of decimal places that you want to format it. Obviously, currency is good with 2 decimal places. And we'll say from the product table. Now we'll see we get 2 decimal places. Well, this was already how it was, but look at the ones that are over 1,000. We now have a comma at the thousandths place. So we know that our format is working. It's giving us also a comma at the thousandths place. In different parts of the world, commas might be in different areas or numbers might be formatted a little different. So there is a third optional locale code that you can throw in there. For example, this one's English US. So we use the comma at the thousandth spot in the US. So that gives us actually the exact same results. But if there is a country that has a little different way to format numbers, you can use that third parameter if you need to. Okay, now if we wanted a dollar sign also here, it would simply just be concatenated on with the concat and just put your dollar string as the string or dollar sign as a string you want to add to the next part of the string, which is this whole thing here. Then you need to end your concatenate paren, opening and closing for concatenate, and an opening and closing for format. And if you run that, we now have a dollar sign at the beginning. You can even put a space before your dollar sign, whatever you wanted to do. Okay. So that's how you might make your currency look a little bit more like currency if you needed to. All right, let's look at some date functions. So say you had a date in your database, but you wanted to just grab out part of that date, like just the year from the date or just the month or just the day. You can use these different date formats. For example, if you use the year function, I was saying format, I meant function. If you use the year function, you can extract out just the date or just the year from the order date. And so now we can run that from, and this is actually in the customer order table, and it grabs out just the year part of that. So you see order date was actually the whole thing with year, month, and day, and we extracted out just the year part of that. If we want to grab just the month part of it, we can put month. If we want to extract just the day part of it, we can put day, and those parts will get extracted out for us. So if we don't want to deal with the whole date, we want to just look at different portions of it, that's what you would use the year, day, and month function. All right, let's do another date one. This one's cool. So you can get your current date as of right now, today, by using the now function. Okay, so this is just coming from my computer system's clock, and it knows that the time I recorded this, it was June 12th at this exact time. So when you run it, it will have your date of today. Okay, so notice here's a function without any parameters, but it still has those parens, so it still is a function called now. Okay, if I wanted to now extract out just maybe the hour from now, so we can do that with time as well, put an ending paren for hour, I can get just, it's now 12 o'clock. Okay, I could have also gotten the year out of there. The year I did this was 2020. Okay, so there we go. So a function inside of another function, this one's getting the entire date and time string. This is extracting the portions out that we wanted to, in this case, the year. All right, what if we wanted to figure out the difference between two dates? Like the customers ordered this date. How many days then did it take for it to actually ship out? So here's the order date, here's the ship date. How can we find the difference between the two? There is a function called dateDiff. And all one word, no spaces, no underscore. And we're going to put the later date first if you want a positive number. So we want to find out the difference between the date it actually shipped and the date that they actually ordered their order. And this is again from the customer order table. And what that's going to give us is the number of days that there are different between those two. So they ordered one day and then 2 days later, in this case, it was shipped out. So 3, looks like 3 is kind of our longest one, so it takes us about 1 to 3 days to get an order shipped out into the mail. Okay, so we're seeing the difference in days. So dateDiff will return the difference in days. What if this was a much later date, like today, and we run that, and it's still going to give me the difference in days, but you'll see that's like many years different, right? So in order to get the difference in years, you would have to divide that by the number of days in a year, and it would say, okay, it's been like 4.5 years, 4.4 years since they ordered between now and when they ordered, because this database had some pretty old dates in it. Okay, so that is what dateDiff is doing. You could even type in a date and I'll just sit there and see the difference there as well. Make sure, okay. Okay, so I put the day's date as well, but you can put any date there. Okay, so that's dateDiff, difference in days between two dates. If I reversed those and put the later date second as the second parameter, I will get a negative number, which is fine. It's the exact same difference, but it's just like putting a, subtracting a larger number from a smaller number, you're going to get a negative. So just realize that so I usually try to think the later date is going to go first if I want a positive number. So that's how dateDiff works. Okay, let's look at dateAdd. Okay, so what if we wanted to add a date, add a particular interval of time to a date? For example, once their invoice hits 30 days, we want to charge them extra interest, or within a week, we want to make sure that they're warned that they haven't paid yet, or whatever it might be. So we're going to go ahead and look at the difference in interval times there. So we're going to say select the order date, and we're going to actually just put that there so we can see it, so we can see the difference. Now here's where our function starts. It's dateAdd, and this time you put an underscore in it. So remember, it's not the same as dateDiff in syntax wise. You're going to actually have an underscore between there. And the first parameter is what date are you going to be adding something to, the order date. And we want to see what the date is in 9 days after the order date, because we're going to do something 9 days after they order. In case it hasn't shipped, maybe we'll do something or whatever. So we say keyword interval, which you always need with dateAdd, is in the second parameter. And then how many days do we want to add to it? 9 days. And remember, no S, just 9 day from the cust order table. And that we'll see, if you look at the days, we have the January 1st changes to January 10th. And then, adds 9 days onto it. Okay, you could also add 9 years. So it's going to go from 2016, whoops, no S. Hold on, I don't know what I'm doing here. Okay, there we go. it's going to go to 2025 because we added 9 years onto it. You could also do month. You could add 9 months onto it. So it goes from January to October. Okay, so you can add an interval of time onto a date so you can see when that would be. All right, almost done here. Just a few more. Okay, we're going to look at the date format next. Okay, for date format, this just means that so far we've seen the date in year dash month dash day, and that's the only format we've ever seen it in. What if we want to see the date differently? We want to make it look like the word January 1st with an ST, 2020, and so you just want to make it look a little different. This is what the date format is going to do. So date format, what date are you formatting? We'll throw an order date again. And then the second parameter is really interesting. It's a collection of little codes. And I gave you a little table in your reading that showed some of the different codes. There's lots of different codes. You have to maybe look them up if you don't have them memorized. So they're format code descriptions patterns. And so just by looking them up, you would know that maybe they all start with %. %, capital M happens to be the week, the month, day, name, like January spelled all the way out, or June, or whatever. And then you might want to say %, capital D happens to be the day of the month with a suffix, like first, second, third. And then the year, the %, capital Y happens to be a 4-digit year. Okay, so you can get 2-digit years, you can get all sorts of different symbols out there. So that's how your second parameter is going to be, and you're going to have it in quotes because these are like string literals. You can actually put, let me run this so you can see, you need from the customer table first, or customer order table. Okay, so there, it looks different. It's the same date, but you formatted it different. You've given the name of the date, the one with a suffix, so you could even put strings in here. You could say January the 1st. You could put dashes here. You can even change these. So, for example, the numeric month is C, and the day of the month numeric without the little extension on the end is E. We do a lowercase y. It's the 2-digit year. We can put slashes in between all these, and we can get all these different formats. So you can format in lots of different ways. So this is kind of cool, the second parameter that you use with date format. Okay, so we have there's lots of other functions out there that we haven't covered, but these are some of the more common ones. But go look some up, like there's a really cool one with replace. There's all sorts of other cool functions that you can look at, but we're just kind of introducing functions at this point and looking at some of them. Locate and substring are probably the most complicated ones that we've seen, but they all have a very good use, and like I said, you'll use some with other functions. In your homework, you're definitely going to be using some functions as parameters of other functions. So it's all about the problem solving sometimes with functions and really digging into exactly what you need from this. So hopefully these common functions have helped you understand what a function is and how they work.